So the Dencun hard fork, it happened 2 weeks ago. Who here knows what happened in the Dencun hard fork? Good. Well, we will talk all about that. Or actually, a lot of things happened in the Dencun hard forks, including things that I care about, like almost removing the self-destruct opcode. But the thing that we'll focus on is the blobs, right? So blobs are what's also called EIP 4844, also called proto-dank sharding, is the main feature that was introduced in the Dencun fork. And the point of blobs was to give layer 2 projects, particularly rollups, some like extra separated space on the Ethereum chain that they could use to store data, right? So rollups are very general purpose, but rollups also have one property, which is that for their security, rollups require putting data on chain for every transaction. Now, before, rollups were doing this by putting everything into call data, right? Putting everything into the data of a transaction. The problem with putting everything into call data is that the EVM has access to call data. And so if something is in call data, it needs to be broadcasted with the block. Whoever is verifying the block needs to have access to all of the data. Even if they're not using the data, they have to have access to it because they might use the data. And so there were a lot of limits to how the efficiency of the data that was being included on chain, and that put a really big and a really low limit on the size of data that we could actually afford to put onto Ethereum blocks. So in EIP 4844, we decided to create a separate section of data that we call blob data. Blob data cannot be accessed by the EVM. But blob data can be used by these layer 2 protocols to store the data on chain, and Ethereum would guarantee that the data is available for anyone to download it. But aside from that, it's completely separate from data that is intended for execution. So the blobs got released 2 weeks ago, and a lot of rollups were immediately ready to go to switch from using call data to using blobs. One more important thing to understand about blobs is that blobs also have a separate fee market, right? So before, in Ethereum blocks had a gas limit, right? So 30 million gas limit, 15 million gas target, and every resource that a contract or a transaction could use was priced by like some amount of gas, right? So who remembers the basic amount of gas in one simple transaction? It's a number. Anyone want to shout it?
Yeah, go ahead.
It's when you that's the Bitcoin cap. Anyone want to shout it?
Is it so?
Yes. Yeah, you got it. Amazing. You got both of the most important numbers in crypto. So that's, someone make sure he gets one of those like $500 credit hackathon prizes, please. So blobs, now what blobs do is blobs have a separate fee market, right? So in a blob, we basically, there is a separate blob limit. So a block can have a maximum of 6 blobs. The target is 3 blobs. And if there's more than 3 blobs on average, then the price of a blob goes up until the number of blobs decreases again. Each blob is 125 kilobytes, right? So the Ethereum chain is targeting right now 375 kilobytes of blob space every 12 seconds. Now, up until about 2 days ago, still some applications were using blobs, but less than 3 blobs per block. And so up until about 2 days ago, blobs were like basically free. Now, you still have to pay the 21,000 gas to submit a blob, but that 21,000 gas is like very cheap for 128 kilobytes. Now, or 125 kilobytes. Now, about 2 days ago, blobscriptions started using blobs. So blobscriptions is it's connected to inscriptions, NFT project. It's the thing that cool kids call a sovereign rollup. But they started using it, and the usage just like immediately went up, and blob fees started spiking up. And blob fees are now like a little bit higher than before, right? So the cost of submitting a blob right now, like we can calculate it, right? So the base fee, I don't know where it is now, but like about a day ago, it was around 10 gwei. 10 gwei multiplied by 125 kilobytes. So that's 1.25 million gwei, 0.0012 ETH. So about $3 to submit a blob, right? So a little bit more than what you need to submit a transaction, but it's still very cheap if you take into account that within a rollup, one blob can contain many transactions, right? So blobs really increase Ethereum scalability by giving this space to the Ethereum layer 2 ecosystem. Blobs make layer 2s more scalable. Now, EIP 4844 is intended to lay the foundation for future scaling. So today, the target is 3 blobs a block. In the future, we want the target to increase more. And the eventual goal is for the target to be 128 blobs per block, right? So 128 blobs multiplied by 125 kilobytes in a blob. Anyone feel like doing the math? How many megabytes? Okay, it's 16 megs. So 16 megabytes per slot, right? So basically, now what does 16 megabytes per slot? 1.33 megabytes per second, right? And in ideal rollup would only use about 20 bytes per transaction. So 1.33 megabytes divided by 20, so basically about 70,000 transactions a second, right? This is the long-term goal of where we want Ethereum to scale to. We do not have 70,000 TPS now, right? This is not today, this is not tomorrow, this is not next year, but this is the long-term goal. The important thing to understand about EIP 4844 is that it doesn't give you that much scaling, but it lays the foundation that makes it much easier for us to continue building and level up to that level of scaling in the future, right? So how do we do this? Blobs are future-proof, right? So we did this very big hard fork that also required very big changes to rollups to actually use blobs. But now, from this point forward, all of the work that is done to increase scalability, to be able to process more blobs, can be done in the background. It does not require changes from rollups. It does not require changes to execution clients. The only hard fork that is required is changing a parameter. Actually, if we had designed it so that you could vote on the blob limit the same way that you vote on the gas limit, then we would be able to upgrade eventually to 128 blobs in a block without doing any hard forking at all, right? So big change today in order to make it possible to scale further without doing any more big changes from the user's point of view in the future. So users today, or nodes today, verify blocks by downloading all the blocks. In the future, we expect users to use a technology called data availability sampling. Instead of downloading a full block, you only download a few random pieces or from each blob, and there's mathematical reasons why this is actually a good enough way of verifying that the entire blob is available. So the next step is a strategy called PeerDAS. PeerDAS is a very simple form of data availability sampling where each node would still store, let's say, about 1/8 of all the blob data. And then every node, when it samples, it would basically ask for the other pieces of data from a node's peers in the network. So if a node stores 1/8, then we could scale by like maybe 8x. I mean, actually it would be 4x, right? But like still a significant amount. Then in the future, we can go from pure dust to doing full data availability sampling, which is what we need to actually get to 16 megabytes per slot. So this is where the protocol will go. Now, rollups themselves, so layer 2 projects, also need to improve. Who here is working on a layer 2 project? Good. Okay, so rollups need to improve in 4 areas. So one is data compression, right? So today, a transaction, uncompressed, naive, takes about 180 bytes. This is like simple ETH transfer, actually no, simple ERC20 transfer, right? ETH transfers is a little bit smaller, ERC20s is 180 bytes. Now you can compress that data, and there's different forms of compression that you can use. So if you use the most basic form of compression, 0-byte compression, like compress, let's say 50 0 bytes into like 1 0 byte followed by the number 50, and that's all you do, right? Very simple compression algorithm. You could have implemented it when you were 14. That gets you down to like maybe 140 bytes. Then if you do ideal stateless compression, then it might get you down to actually about 120 bytes. And then if you also do signature aggregation, like BLS aggregation, or zk-snark signature aggregation, then you could go down to 75 bytes. If you do stateful compression instead of stateless, then you go down from 75 bytes all the way down to less than 25 bytes. Now, what does stateful compression mean, right? Let's say I create a new account, and I send a transaction from that account. My address is 20 bytes. That address already went on chain once. The next time someone sends a transaction to me, or sends me coins, or I send a transaction to someone else, we don't need to put my address. Instead, we just put a pointer to the location on chain that had my address last time. A pointer on chain, let's say there's 1 trillion locations on chain, right? Then the pointer would only be 5 bytes instead of 20 bytes. And actually, if you do like statistics, you can optimize that more. Probably it's 4 bytes or maybe 3 bytes. So that way, basically you can see here, right, that on the left, 75 bytes, you had addresses. Addresses take a lot of space, right? See the one purple and the 2 beige, like big boxes, addresses. On the right, each of those go down from 20 bytes to 4 bytes, right? So ideal compression, very powerful. Now, so data compression is one really big and really powerful thing, right? Actually, if someone wants to do a hackathon project, just do like stateful data compression of the Ethereum history and just see how much you save. Like that by itself, I think is useful already. Optimistic data constructions. So who here remembers Plasma from like 6 years ago? Amazing. So optimistic data constructions, right? Data constructions where data goes off-chain, but only if there is some kind of problem. If someone needs to deposit, if someone needs to withdraw, or if there is an attack. Only in an exceptional situation do you actually put data on-chain. Now, it turns out that Plasma is easy to do for some limited set of applications, but you can't fully do it for the EVM, but you can almost do it for the EVM. And there are things that are almost like Plasma that can protect you that have like a cost that's somewhere in between Rollup and Plasma. So if we do this, then like this can also increase a Rollup's security even more, because then if data goes off-chain most of the time, you can go even lower than 23 bytes per transaction. So lots of projects already looking into this, I think also very promising. Parallelization and storage improvements, right? So this is a chart of the usage of Base. Who here wants to guess what happened over here right before the Base usage went vertical? Any guess? Yes? No, it's the Dencun hard fork. Basically, the Dencun hard fork made Base 100 times cheaper. And when Base becomes 100 times cheaper, everyone wants to use Base. Now, here's the problem. People loved using Base so much that Base hit hit its own gas limit. Like Base hit the gas limit that it had internally to deal with the amount of EVM computation inside of Base. right? And so what happened was that then the gas limits or the gas price within Base started increasing. And at one point, Base even got more expensive than Ethereum. So this is a problem, and Base computation needs to go or needs to really upgrade a lot internally. And actually, yeah, Jesse Pollack has been yelling a lot about this on Farcaster, and I think he's completely correct too. His dream is to get to 1 billion gas per second, and he is absolutely correct that eventually we need to get to 1 billion gas per second. But this means scaling execution of layer 2 EVMs. This can mean parallelization. This can mean doing a better job of storage. It needs to mean a lot of things at the same time. Also an important challenge. Finally, improve rollup security. So most rollups are still basically multisigs. These are the 5 that are not. So everyone, let's give a round of applause to the 5 Ethereum rollups that are not multisigs. So if you have a rollup, I want to see your name on this list within a year. So zooming out a little bit, right? Ethereum's S-curve. Basically, yeah, this is a diagram that I published about 2 years ago. So about 2 years ago, I published a diagram that looks like this, except it only had the arrow at the bottom. And basically it was saying that we are, right now, meaning in 2022, entering the period of the most rapid change that Ethereum is going to go through, right? Meaning, number 1, proof of stake, and number 2, data sharding, which has now become the combination of rollups and data availability sampling with blobs. Fast forward 2 years later, we've the merge, we've moved from proof of work to proof of stake, 99.9% less energy consumption, good. Also better finality, good. Now, at the same time, we also moved to blobs, and we also, I think, at an ecosystem level, are basically more than halfway there in moving to layer 2-centric Ethereum, right? So who here has sent a transaction on a layer 2 in the past week? Who here has sent a transaction on a layer 1 in the past week? Okay, see, same number of hands went up, right? So about halfway there. So 2 years ago, this would not be the case. Now, 2 years ago, right, we were at the spot at the bottom. Right now, we're at the spot at the top. And so I think we have actually already passed through the most dangerous parts of the storm. The work on the layer 1 is still important. Vertical trees are, I think, the most difficult remaining piece, but the work is more incremental, right? Everything that happens from here forward is relatively easier and relatively milder than what came before. What this means is that work now is a little bit less on layer 1, but much more on the application layer. So this gets me to my next point. So who here remembers when, about 7 years ago, I made a comment that the Internet of Money should not cost more than 5 cents per transaction? Who here remembers Bitcoin maximalists laughing at that? So this is a chart of fees on layer 2s. Who here can see how many of them are less than 5 cents per transaction? Come on, this is a check. Who here can see? Okay, so we have one, right? But what this also means is that as an application developer, you cannot hide behind the idea that, oh, well, we can't build decentralized things that can achieve mass adoption because fees are too high, right? This is no longer an excuse. What we need to do now is we need to build applications that are both open and decentralized and that follow all of the best standards in terms of things like being open source, in terms of being on chain, in terms of not having central points of failure, all of these things. But at the same time, make those applications be applications that are easy even for non-crypto people to use, and build applications that people want to use even if the reason why they're there is not to make money. So who remembers the kind of crazy wave of, what so-called social fi for the last 2 or 3 years? Who here remembers feeling very frustrated by that? Okay. Now, I think today, no picture here throughout the picture, unfortunately, but the Ethereum ecosystem, I think, is really rising to the challenge, right? So if you look at Farcaster, I think, is one of my favorite applications because it does a very good job of being like very blockchain-based, open, decentralized, all of the right things, and being very user-friendly at the same time, right? Like, this is amazing. That is the kind of standard that everyone here should be building to today. And Farcaster is not the only one, right? Also, Lens, I think, is getting better and better. And Dymo, which is a Ethereum wallet that is based on Base. It's trying to be as convenient as Venmo. So we're really seeing that next wave of Ethereum applications happening right now, right? So basically, now that we have lower fees, now that we have better user experience, better convenience, we actually can do all of these things, right? And I think the ecosystem as a whole really needs to level up to get to that standard. Now, building for Ethereum in the 2010s versus building for Ethereum in the 2020s, right? So 5 years ago, building on Ethereum was like very simple, right? Where do you put things? You put things on layer 1. How do you store the data? Everything is public. If you need some kind of anti-Sybil mechanism, if you need some mechanism to prevent people from just creating a billion accounts and spamming the system, well, then you just require users to put down 0.01 ETH. What wallets do you have? Externally owned accounts. If you need a proof of community membership, like for voting or for airdrops, what do you do? Well, you vote based on how much ETH you have, right? These were the answers 5 years ago. Today, we have much better answers for all of these, right? So architecture. If you're building an application, then either you build on one specific layer 2, or you design the application in such a way that it supports every layer 2 that follows some standard, right? So like, for example, every layer 2 that's EVM compatible, and you're just automatically there. So for example, if you're building just like a market for people to trade coins, just as a convenient way of moving from one place to another, it needs to support every layer 2. If you're building like some complicated DeFi derivatives thing, it's probably easier if you just build it in one place, right? So one big decision for everyone building an application is be on one layer 2 versus be on every layer 2s. And I think the difference is like, are you building a node or are you building glue, right? If you're building a node, then you're on one layer 2. If you're building a glue, then you're on every layer 2. Privacy. We now have ZK snarks, right? Data should not be public by default. A user's data should be private by default, and users should Merkle prove or ZK prove specific things if they need to prove those specific things to establish trust, right? This is how reputation systems can work. This is like how privacy preserving financial systems can work. This is like how proof of personhood systems can work, right? Like that level needs to be the standard. Anti-Sybil. So applications can require an ETH deposit. They can require a payment, but clients, meaning applications, they should offer wrappers for non-crypto users so that if you authenticate yourself some other way that that non-crypto people have access to, then the application handles the crypto part for you. Right, so Farcaster does this, right? So the Farcaster chain requires some amount of cryptocurrency to register an account, but Warpcast a client, it just creates an account for you if you join and if you provide your phone number. Wallets. We have account abstraction wallets, right? So supporting key recovery, supporting the ability to have different levels of access control for different actions. It should be easier to send $20 than to send $200,000. Sponsored transactions. So if all you have in your wallet is USDC, you should be able to pay your fees in USDC. And then for proof of community membership, we have ETH. We have proof of personhood protocols. So, we have Circles, we have WorldCoin, we have proof of community, we have Bitcoin Passport, we have POPs, we have Zoo Stamps, we have Ethereum Attestation Service. We have third-party curated lists, so like the Starknet airdrop solo staker list. So if you're doing an airdrop or if you're doing a voting thing, you can basically try to support all of these. So conclusions, right? So Ethereum is decisively shifting from rapid layer 1 development to still important layer 1 development, but a lot more things at the application layer. We still need to finish scaling. Applications are no longer prototypes. Anything built today needs to be mass adoption ready. And finally, Ethereum is not just a financial system. Ethereum is now a whole independent tech stack that includes components for identity, components for reputation, naming, trust, decentralized storage, more and more, all kinds of things. And basically, applications should build accordingly. So, thank you.
Yeah. Q&A time?
Yes.
Yes, let's look at the laptop together. 저희 질문 주신 거 조금 해볼게요. Yeah, let's do it. Remember we did the scrolling? Yeah, so we have a bunch of questions. So you can scroll up and then see. 저희 질문이 좀 많이 들어와서 좀 scrolling 해보겠습니다.
Yeah, okay. Are you bullish with Ethereum? I think I'm more bullish on US dollars,
Oh, really? That's questionable. Really? Are you sure?
Okay, fine, Bitcoin.
Bitcoin. Oh, so it's US dollar, Bitcoin, and Ethereum?
Solana.
Oh.
XRP.
Oh, wow. We're going
Ethereum Classic.
We're going really full throttle here, huh? All right.
Yeah, come on, DGen. It's the decentralized generation, right?
The meme coins, yeah?
Yeah.
All right.
Okay. Where is my next destination event? Actually, after this one, I'm going to be quiet probably, for a while. Yeah.
Quite a travel, right?
Yeah. Do I feel any pressure that people have their entire net worth on Ethereum? I mean, yes, absolutely. Okay. Great. Well, I'm feeling great too.
Yes, we're all feeling great.
What is my favorite L2? I mean, I like all of them. I'm really curious if you're a human born on Earth. No, I am a dog. How do you predict the future of Bitcoin and Ethereum? I talked about Ethereum for 20 minutes just now. I think for Bitcoin, it's... the interesting thing that's happening with Bitcoin, right, is that there's this growing Bitcoin L2 community, and there's first inscriptions, but now there's BitVM and a growing number of things. There's talk of doing a hard fork for Covenants. I think that stuff is powerful because it feels like the Bitcoin cultural vibe is turning back toward builders. For a long time, it was laser eye people who just wanted to eat steak, and I personally don't like steak, but I like builders. It feels like it makes the culture healthier. So I guess the big question is how much will Bitcoin really actually be able to accomplish with layer 2s and with all of these tools? One thing to keep in mind, right, is that BitVM is great, but it does have a lot of limitations, right? It's a 1 of n system. It has a 1-week withdrawal time, and then any one of the n guardians, I believe, has the ability to basically block withdrawals from the system for quite some time. So it's not perfect, but it is improving. I definitely hope Bitcoin improves more. How do you see the future of Ethereum? Already answered. What do you think is the best chain other than Bitcoin and Ethereum? The best chain, the Starbucks count?
Starbucks.
No. Is there a specific FHE scheme that you think is ideal for blockchain and FHE/ML? Good question. I definitely feel like I haven't caught up with specific FHE encryption schemes for the last couple of years, right? I did my deep dive on how FHE works. I wrote a blog post on it about a few years ago. If you just go to my blog and you just search fully homomorphic encryption, if someone wants to understand how it works, then you just read through that and check my Python code. But I admit I have not looked up optimal algorithms since then. But it's definitely an important space.
Sure.
You mean chat?
Yeah, no, this is cool. Could the Ethereum Nomad community become a verification organization that inspects and checks for node verifiers that are verified to become independent? Could this become part of the protocol? I think those kinds of trust layers are really, interesting. I definitely want more of them to exist, and I think they would be valuable for things like off-chain voting systems and DAOs and airdrops. I think for the Ethereum protocol, core developers would probably be too uncomfortable about like making something really complicated like that be a dependency of the Ethereum protocol. But the reality is, like, even one well-executed airdrop can improve incentives for Ethereum staking, right? So I think there's a lot of room to try to do a lot of those things independently. Yeah, I mean, I definitely support Ethereum nomad communities. I think they're great. What hard problems in Ethereum keep me up at night? I mean, the big one I haven't talked about so far is, one is staking centralization, and two is just like, can we get to a point where all of these like layer 2 verifiers and other really complicated things actually don't have any kind of software bugs? I think it'll be a big challenge. Let's see. This year is set to be the year of institutions entering the crypto market. How do I see the Ethereum ecosystem changing as institutions enter the space? I think like there's different kinds of institutions, right? Like there's organizations that just wants to come in and buy coins. And I think if they participate, the answer is not much. Like, obviously, if someone buys coins, the price of that coin is higher than if they did not buy coins. But like that doesn't affect the character of the ecosystem. I think if we see institutions more actively participating in Ethereum at the application layer, that would both bring more scale and bring more risks. Like the scale is good because it brings in more people, and I mean, like it really helps to normalize a lot of the ideas in the space. But at the same time, the risk is basically that like if they come in and they create something that like totally does not fit with the values of the space, then like could that end up derailing things? Or could that actually be like a positive counterweight to, you know, like some of the degen stuff? I don't know. What do I think is the reason for the ETH price being inactive? I honestly have no idea. 2 weeks have passed since Dencun. Are we seeing a change? Yes. So I could give some interesting examples of a change. Here, I'm actually going to show something right now. Can we make this English? Okay. Yeah, I have just like one interesting chart to show.
이거 하면 띄울 수 있어요.
Okay, fine. I have no idea how to do this, but
Oh, do you want
yeah,
Korean?
yeah, no, I just webs. Oh, there we go. That's what we need. Okay, etherscan.io/chart/tx. So if you go here, this is a chart of how many transactions per second we've seen on Ethereum, right? So transactions per second. Now, okay. Oh, I see. Oh, sorry. I just clicked on don't tell. Did I just?
안 되나?
Sorry. I just accidentally clicked don't allow because I have an instinct of clicking don't allow on things, but I think that was wrong. Okay, so this is a really important chart to look at, right? Because over here, this is like basically the peak of like Ethereum transaction capacity. This is when the Ethereum gas target went up to 15 million, right? But then it went down. The reason why it went down is because we actually started to see a lot of rollups, right? And rollups, they use a lot of gas, but they're much fewer as a number of transactions, right? Like if a rollup submits a really big batch, that's one transaction. It might take up like several million gas, right? But it appears as one transaction. And so what the decrease we saw over here, the decrease going from here to here, is basically because activity moved from layer 1 to layer 2. And layer 2s still take up some amount of space on layer 1. And so that decreased the amount of room for layer 1 native activity. Now, if you go over here, you notice that the pattern completely reversed, right? So basically over here, you see how the decrease in transactions per day from 2021 to 2022 has basically completely reverted, right? Like right now, we're basically seeing like approximately all-time high levels of kind of like stable activity, right? And this is because layer 2s have now moved to using blobs, and so there's more space on chain for layer 1s to do regular layer 1 transactions. So this is a big improvement, right? So layer 2s actually have moved over. Layer 2s have become much cheaper, right? So the chart that I showed you about 15 minutes ago, layer 1s now cost like 1 or 2 cents often. Before they cost like 10 or 30 cents. And layer 1, I think, is also becoming cheaper than it otherwise would have been, right? So yes, we are seeing quite a bit of improvements and quite a bit of progress as a result of blobs already.
Are we done, or there's more actually?
You choose when we're done. I'm happy to keep I mean, I did a Lex Friedman episode for 3.5 hours, so...
더 갈까요? Go more? Do you want to answer more questions?
Yeah.
Just anything that you would just...
I know, okay.
prefer.
What is Ethereum's solution to reduce gas fees in the near future? Already talked about that. Do I like the color orange? Yes.
That's why you're wearing it.
Am I vegetarian? I mean, no, but I like vegetarian food. What do I think about eigenlayers and restaking? It's an interesting one. I think... I wrote a post about this about a year ago, right? Like, restaking, I think, has a good side and it has a bad side. And the good side is that, like, if you reuse staked collateral, that can increase the security of a lot of applications. And the bad side is basically that if you do it wrong, then the risks of the applications can end up starting to, basically increase systemic risk to the layer 1 chain itself, right? Basically, the risk is applications try to use restaking to try to drag layer 1 into their own problems. And Ethereum researchers, we've been talking to the team, the eigenlayer team in Shriram, and Shriram actually has, I feel been open and willing to try to change and improve the design to respond to the criticism. So I think that's positive.
This is the new ones.
Oh, I see it. Do I think FHE layer 2s can scale if they need an MFN trust assumption for decryption? I mean, I'm definitely worried about MFN assumptions. The reason why I'm worried is because with an MFN assumption, that's an assumption where 51% can break without anyone ever knowing about it, right? So I think one thing that's important to remember is that 51% assumptions are actually not that stable, right? So there was a famous picture of Bitcoin miners in Hong Kong. Literally 90% of the Bitcoin hash power came together on a panel, right? And so if they wanted to organize a 51% attack, they could. It's easy. The biggest factor preventing them from doing that is not the difficulty of reaching 51%, but the fact that if they did, it would be very publicly obvious that they did. There would be just very easily available evidence of the attack on the internet, and Bitcoin would probably switch to proof of stake and all their investments would go to zero, right? This is what stops the 51% attack, and this is also what stops 51% attacks in Ethereum. With a threshold encryption system, including MPC, including FHE, including everything, the problem is that 51% can collude to decrypt all the data without anyone else ever finding out, right? And so they could just quietly decrypt, use people's secrets, steal money from whoever they think is inactive, and no one would ever be able to prove it. And this to me feels more scary, much more scary than a regular 51% assumption. So this is the reason why, to me, 51%, I'm more worried about these MFN assumptions in threshold encryption than I am for blockchains. And so I think when you have to use an MFN assumption, you should use it. When you don't, then I think you should just use things on a regular blockchain and try to do as much as you can with regular blockchains and with ZK snarks.
Maybe a few more.
Sure. Do I anticipate that Ethereum can be a storage system once full DA is realized in the future? I think... So 16 megabytes is a lot. That's 1.33 megabytes per second. That's if you divide by Earth's population, that's basically a byte per person per 1,000 seconds, right? That's not enough for the activity of humanity. That is enough for possibly a very limited amount of data like blockchain transactions, but there is much larger amounts of data for whom even 16 megabytes per slot is just nowhere near good enough, right? So for example, NFTs. NFT transaction, one NFT transaction, if you do all the compression, you can compress it, you can make it be 16 bytes, you can maybe even make it 12 bytes, right? You don't need the balance, so it's just, the balance is 1 bit, so it's 12 bytes. Now, but then NFTs also have pictures, and sometimes they have videos, sometimes they have GIFs, sometimes they have GIFs, sometimes they have audio. That's a lot more than 12 bytes, right? So let's imagine 10 million people being NFT traders. let's say on average, one of them makes one NFT trade every month, right? 1 month has 2.5 million seconds. So 10 million people divided by 2.5 million, that's going to be about four per second. So then if you think about like the just like raw transaction data cost of that, then that's like tiny, right? That's like almost nothing. But then if you think about the costs of, let's say, an image for each one of them, right, then that goes up to like 100 kilobytes per, let's say 100 kilobytes per image, multiplied by 4, and you're talking about like 400 kilobytes per second, right? So that's already 1/3 of the theoretical end goal of Ethereum capacity, right? And so we still need off-chain stores of data that have less guarantees than blockchains, but that are still decentralized. And so we need Filecoin, we need IPFS, we need other things like that as well.
Okay.
Privacy is important UX. How and when will we get privacy? What is importance tech? Who here has used Railway? Who here knows what Railway is? Who here wants to know what Railway is? It's a privacy system, so railway.xyz is the address. Basically, the idea is that you can send coins in, and then you take coins out, and it uses ZK snarks so that like there's no public link between the coins that get taken out and the coins that get put in. Railway, it also uses an interesting technology called proof of innocence, which basically says when you take your coins out, you're also making a zero-knowledge proof that says you're not revealing who you are, but you are publicly revealing that you're not any of the people who are known bad actors, right? So like if, for example, someone hacks a DeFi protocol, takes out $50 million and dump it all into Railway, then everyone else's proof of innocence is going to automatically prove that they're not one of them, right? And so the attacker will not actually be able to mix their coins with anyone except for other attackers. So it's actually like an interesting example of like providing very strong privacy for users, but also minimizing bad actors' ability to use the system, which I think is really powerful, right? But I mean, I personally need to use Railway because like, if I don't use strong privacy technologies, then like half the internet comments about every transaction I make. And it's like, oh, is Vitalik selling his ETH? Well, no, Vitalik is like donating $75,000 to a charity. So I think Railway is a good example. In the non-financial space, I think privacy around like identity and around reputation and around voting is also valuable. So this is why I've been a big fan of ZooPass. This is why I've been a big fan of ZK voting systems. Macy, I'm actually a hackathon in Vietnam ended up actually using Macy for voting, which I think is really cool. So maybe someone here could make a Macy-based voting app, and then it would actually get used for the votes at the end. Yeah, sure. Let's see. Is there a particularly fun one? Do I think SocialFi needs? I mean, I hope the term SocialFi dies. I hope we switch to decentralized social, because the point that the thing that crypto brings to social should not just be being able to like speculate on other people, right? It's like the nice thing about Farcaster is that people use Farcaster even if their goal is not making money. Let's build more of that. What is the ideal future L1 gas fee? As low as possible, as long as there's still a small enough amount of usage that people can verify it.
Do you like golden retriever?
Do I like golden retrievers? I mean, wow, that's a good question. I mean, golden retrievers are fun. Shiba Inus are fun. Huskies are fun. I think all dogs are fun. I think cats are fun too.
Absolutely. Mm-hmm. Thank you so much for the vast Q&A. But let's give a big round of applause for Vitalik. Mm-hmm.